Good evening, everyone. My name is Suresh. I am a senior solutions engineer with Sumo Logic, and a warm welcome to all of you for the AWS Observability live demo today. I am going to be your host for the day, and I'm going to walk you through the AWS Observability solution from Sumo Logic. Before we get on with the live demo, few housekeeping items. There is a Q&A button in the webinar panel. So feel free to click this and then ask all your questions there. At the end of the live demo, I will try to answer all of your questions to the best of my ability. We will be providing you a live recording of this particular demo, post this particular session. So you can always revisit this and then you can watch the live demo anytime. Having said that, let's move on to the AWS Observability solution. Most of the customers today with Sumo Logic, they use AWS predominantly. While we see multi-cloud adoptions over there, AWS is one of the primary environments that we see with our customers today. And working in AWS also means that the customers use numerous different services from AWS, and you can see the adoption of services. The average or the median number of AWS services used by enterprises has jumped up from 15 to 26 in the year 2020. And 2021, you can expect even more services to be used by the customers. And there are more and more services getting adopted by the customers from AWS. All of this results in much more complexity. You can see some more statistics about the customers who use AWS. There are a lot of customers who use multiple AWS accounts, as well as a lot of customers who use multiple regions as well. So having the applications infra deployed on cloud also means that we need to handle the application architecture complexities as well. There are numerous services which are interrelated for us to deliver a service to our customers. So the visibility is fragmented because the request or the transaction has to go through multiple different services, and all of this creates a complex chain of dependencies which each other. You may be seeing an impact on one of your services, but then the impact may be caused due to the third or the fourth layer on which your services are interacting. It can be because of your load balancer having issues. It can be because of capacity issues. It can be an error faced by one of your dependent services in between, right? So how do we effectively troubleshoot this complex interrelated applications together? That's what we are going to see as part of this AWS Observability solution from Sumo Logic. AWS Observability from Sumo Logic. We have three components here. One is the out-of-the-box dashboards that you get. There is a seamless integration, which you can do using the CloudFormation template. And once you bring in the data into Sumo Logic, we provide you out-of-the-box content, which gives you AWS observability-related dashboards, Explorer views, etc. So we'll look at the AWS Observability components as part of the live demo today. And we also have a root cause explorer, which helps you to understand the interrelated services. It shows you which are the services which have impacted, which are the services which have actually deviated from the normal. It uses a lot of machine learning aspects. We understand the relationship between various components within your AWS environment, and we show you how you can quickly accelerate the issue resolution. We will show you a couple of examples for that today. With the AWS Observability solution, we can show you your AWS environment in one single pane. You don't have to navigate between multiple different screens. You can see your AWS environment in one single page, like how the Windows Explorer looks. You can look across your account. You can look across your region, namespace, as well as various different hierarchies out of a single pane of view. There are numerous out-of-the-box dashboards which are available, which covers numerous services like the ECS, RDS, Elastic Cache, the AWS API Gateway, Lambda, DynamoDB, Application ELB, and Network ELB. If you want to integrate more services, then we have a mechanism by which you can bring in additional dashboards. You can bring in additional services as well as part of the AWS Observability solution. Having said the AWS Observability solution, you would be thrilled to see how a root cause explorer works. End of the day, it is all about what is the root cause that we are all looking at when something goes bad. So with a root cause explorer, we can show you what is actually contributing to some service actually going bad. It can be because of errors, it can be because of availability issues, or it can be because of load as well, throughput related issues, or it can be because of things like, say, for example, abnormal latencies, etc. So we can show you where your particular app is actually having problem, as well as we can show you the dependencies as well. So you can quickly, I would say, narrow down, and then you can find out what is actually causing your application to face issues, and then you can quickly resolve the issues over there. There are 14 different services that we support for the root cause explorer today. Once we get into the solution, we can have a look on that. Having seen all of this, you may be thinking that's going to be very complex to set up, because we are talking about multiple different services from which we want to bring in data. We want to do correlation of that. We want to give you root cause explorer, etc. So it is pretty simple. Sumo Logic has actually made the setup of this particular solution pretty simple. We provide you a cloud formation template. So using this cloud formation template, you can quickly do an integration. Basically, we collect the CloudWatch as well as a CloudTrail logs. And then if you are looking at EC2, then we will bring in the host metrics as well as part of the overall data collection. And once we collect all this data, we do an enrichment of all this data. This is our secret sauce. And once the enrichment is done, then you see those nice hierarchies, the root cause explorers, etc., as part of the AWS Observability solution in action. Having seen that, let's get into the AWS Observability solution now. What you are looking at in the screen now is the AWS Observability solution. You can see there is a left-hand side, we have a navigatable menu, and on the right-hand side, you can see data about AWS environment. We are looking about a demo account here. So I can have multiple AWS accounts. You can see I have a prod account, there is a dev account, there is a staging account, and there is a production account as well. So these are aliases which are given. So you don't have to put an account name, account number here. Having an account name actually helps us to easily identify the environment. So I'm looking at multiple environments here. I can bring in data from multiple different environments, multiple different regions, etc. So I can go into my staging environment. You can see the different regions, etc. Similarly, I can go to my dev environment, etc. I'm going to look into my production environment. So under my prod account, I have two regions, US East 1 and then US East 2. And once I click in the US East 1, then I am actually taken to the specifics of this region. So that is how the Explorer works. So it is pretty easy for you to bring in all the services into one single pane, and then you can view all of this particular data. So in the production account, I can see there is an account overview. This shows some CloudTrail related data over here. This is a correlated panel. So we pick up the IP address from the logs, and we do an external table lookup, and then we pick up details about the latitude, longitude, country name, country code, etc. And then we show in this GeoView, so which helps you to graphically visualize data. You can see the AWS resource activity over here, and you can see a nice summary of the critical services. You can see the application load balancer being shown over here, request served, and I can also see there are a couple of load balancer instances facing issues here, which is shown up as red here. API gateway, you can see some summary statistics. The honeycomb view actually helps us to identify in case some instances are facing issue. Just by hovering on top of the instances, I can see more details about the specific instance over here. EC2, you can bring in the data over here. Lambda, RDS, DynamoDB, you can see Elastic Cache, ECS, and then the network load balancer. You can see all of them over here. What catches my eye here is that I see my AWS Lambda looking like there are a lot of errors which are actually be seen over here, and some issues on the ALB side as well. I see a couple of instances showing up in red over here. So I'm actually going to go one level deeper from my account level. I'm looking at the US East 1 now. I can see the similar data, but now it is drilled down to the US East 1. Some API level, I would say the CloudTrail data over here, resource activities, etc. I can see the ALB showing up some errors. I see Lambda actually showing up a huge lot number of errors. So I'm going to get into my AWS Lambda here. So on the navigation menu, I'm going to my AWS Lambda here. And now I'm looking at the specifics of my AWS Lambda. So you can see the audit caller locations here. You can see the performance today versus yesterday. Duration is today versus yesterday. You can see all those details over here. Tons of metrics which shows the health of my service. Top AWS services using Lambda. You can see all those services here. Top IAM users using Lambda. And you can also see top functions by duration is shown in this particular panel. You can see the average duration, total duration, invocations, etc. And the top functions by memory used. You can see the max memory, average memory used, etc. Also, I can see allocated memory versus used memory. This will be helpful with respect to optimizing the memory allocations, reservations, etc. Right? So I can see tons of metrics over here. What catches my eye here is that I see there are a lot of errors, 7,879 errors. And then looks like the get billing info is the one which seems to be actually facing a lot in number of issues. So what I can do here is that I can go into my function name and I can actually start filtering for my Lambda function, which is actually facing issue. So you can see as I start typing the function name, you can see the auto filter actually populating the available value. So I can simply choose from here. So I am looking at the get billing info. And now this filter is actually applied, and then I can see the dashboard now specifically for the function name get billing info. And when I come down here, I can see there are around 720 errors. I don't see any successes at all. I see all failures over here. A closer look at the table below shows that there are some event names, and I see some update functions over here. Seems to be changes. Changes are the one which typically cause problems. So I would like to go and take a closer look at it. So all I need to do is I just go to this particular panel, and then I am actually going to open it in a search. So now you can see the system automatically opening up the search over here, and I can see the event names. I see there is an update function configuration. So I'm going to get onto my individual messages here. So I'm going to the event name, and then I want to find out update function configuration. You can see the system now automatically filtering all the events for this particular change. And I can actually start looking at this particular detail here. I can see user Mark Smith, and I can see that he is actually making some changes to the Lambda functions here. So some changes are actually being applied over by this particular user. Similarly, I can see some more changes over here, etc. So since Lambda does not show what change it is, but I see that the user has actually made some changes to the Lambda function. As an on-call support engineer, I can reach back to Mark Smith to find out what changes has been done, and I can actually roll it back so that the application comes back to production first, right? So here, what we did is that we went into the Explorer, and from the Explorer, we are able to narrow down to the function which is actually facing issues. We get onto the logs, which actually shows us why the particular function is facing issues, and then we are able to identify the issue and then resolve it quickly. Right. So this is one, I would say, navigation-based use case that you can quickly correlate to see how you can use it in your production environments. So we, as part of the initial dashboards, we also saw the load balancer was actually facing some issues. I can see the ALB. It is actually showing errors over here. So I'm actually going to get into my ALB here. So I am opening up my US East one prod. I'm getting onto my application ELB. I can see all my ELB summarized over here, and this shows the request locations, 4xx error codes, 5xx error codes, etc. It also shows me tons of metrics, which shows various different performance related information about my load balancers. And here I see an interesting panel. So this is my 5xx by load balancer, and I do see that one of my load balancer instances is actually experiencing a significant spike over here. And I actually noted down this event seems to be happening roughly around this 5:30 to 6 a.m. sort of stuff, right? I see a huge spike with respect to the 5xx errors. So I'm actually going to get onto my root cause explorer to see why this particular instance is actually facing issue. So I'm going to my region level statistics now, and I am actually getting onto my AWS region events of interest. So here you are actually witnessing the root cause explorer in action. And here you can see there are numerous events of interest shown here for this particular account and this particular region. You can see throughput variations, errors, bottlenecks, latency, availability, load, etc. being tracked over here. On the x-axis, what we are seeing is the time, and on the y-axis, we are seeing the drift. So this is I would say, an algorithm which automatically tracks what is the deviation of these particular parameters for any of the AWS Root Cause Explorer services, and tells us what is the deviation from the normal. Here I can see, say, for example, I'm actually looking at API gateway error, and then I can see a drift of 124% for 30 minutes, right? So this shows that the event that we are seeing here, where we are actually experiencing 5xx errors on the API gateway, it is compared to the normal, it is actually 124% higher. And you can also see the events shown in colors as well as the sizes. The bigger the size of the event, more longer is the outage of the duration. So here I can see the API gateway, the load. So the load is 157% more for 70 minutes, right? So which is much more longer. So you can see the root cause explorer tracking the common events which cause problems for applications. So throughputs are one of the reason why applications face issues. If there is less throughput, then obviously applications are going to face delays. You can see errors which are happening. If in case there are errors, then you can see that this application face issues. You can see the red colored ones, which are like errors over here, and bottlenecks. Similarly, you can look at latencies, availability issues, etc. So let us delve deeper to see the root cause explorer in action. So here I am looking at the root cause explorer in action here. So here I can see the root cause explorer looking into the details of last 24 hours. And it is actually showing me all the events of interest over here. So I can, just by hovering on top of it, I can find out what this particular event of interest is all about. It can be a throughput issue, it can be an error, latency, etc. It also shows me what is the drift, which is like what is the deviation from the normal, as well as how long that we have actually witnessed this particular drift, right? So it gives us all these three critical aspects, so you can understand what is the impact of this particular event on your infrastructure. So I'm actually looking at the cluster of events over here. So the cluster essentially says that the events which cause an outage are generally related to each other. Say, for example, if there is a service which is facing errors, the upstream service which is actually requesting a connection from the current service which is facing errors will also face issues, right? So the events which are clustered together, which are close to each other, they generally point out some issues which are related to each other. Similarly, the earlier the issue which we see, most probably that is the one which is actually causing an issue. So here I'm actually looking at the region, or I would say a timeline of interest here. I know that my outages happen somewhere around 5:30 to 6. So I'm choosing a range where I see a cluster of events over here. So I'm now able to drill down or go closer into this particular time duration. And here I can see there is a ELB app which is actually showing errors. There is a 729% drift for 20 minutes here. And I can see the events which are closer to it. I can see there is a host bottleneck, the EC2 instances. Actually, they are actually facing some sort of a bottleneck over here. And I see there is some other service which shows some latency issues. And then I can see there is a DynamoDB bottleneck over here, right? So in this sequence of events, the ALB is the one which is actually showing us issues, errors. But then the ALB's in turn is talking to a couple of EC2 instances. EC2 instances in turn is actually interacting with a DB, right? So this is the sequence of events. So I would like to go ahead and then take a closer look here. So I'm going to the earliest event which has actually happened in this chain of events. So I'm going to the DynamoDB over here, and I can see the details about my DynamoDB event. And here I can see a huge, I would say, read throttle events. And I can see there is a 1024% drift for about 20 minutes, right? So I can go to my related infrastructure here, and then I can go to my namespace if I want to do more troubleshooting, and I can open it in my entity dashboard. I can go to log search. I can go to my metrics straight away from here, and as well as my root cause explorer. Similarly, I can go to my region as well, my US East 1 region from here, looking at the errors, and I can also go to the related account as well, right? So I can navigate to all of these related entities or related panels straight away from my menu option here. So I'm actually going to go into this particular entity to take a closer look. So I'm clicking on this entity dashboard. Now I'm seamlessly able to navigate into my AWS DynamoDB capacity planning. And from here, I would like to go and check my events. So I'm going to my AWS DynamoDB events. I can see the events, the locations. I can see a couple of errors over here. I can see top 5 events, top IAM users. Coming down further, I can see some errors here, resource not found exceptions, etc. And then the table events. So what catches my eye here is that I can see some update table, etc. Looks like there are some changes here. I would like to take a closer look as to what changes are actually there. And while we navigated to the specific menu options, you can also see the Explorer has automatically picked up the time range as well from the root cause explorer. So I'm going to open it in a search. Now I can see the search panel is automatically open. Everything is pre-filled. You don't have to fill anything at all. And here you can see the event names here. I see some update table, describe, etc. I would like to go and see what sort of changes are actually being performed here. So I go to the messages and I can see the Explorer here. From here, I'm actually going to look into my event name and I have three options here. I would like to see what changes are being performed. So I am going to choose the update table event. And you can see the system is now automatically filtering out for all the event names which are actually update table. And I am actually looking at this details over here. And here I see some change. There is an update table change. And then there is a decrease with respect to the number of write units, right? So it clearly shows that there is a action which has been performed, and then the user Ankit Goyal has actually reduced the capacity, the DB capacity today, right? So this has actually caused a bottleneck. So we are able to see that the bottleneck which has been created by making a change to the DynamoDB is showing up or it is propagating to the hosts which are accessing this DB, and it is being cascaded to the ALB, which is the client facing or the customer facing ELB. It is showing up issues because we see there is a change in the backend, right? So with the root cause explorer, you can actually get into a quicker troubleshooting mode. You can look at the cluster of events, and then you can also find out what is the drift from the normal. You can also find out the event of interest, which can be latency issues, it can be errors, throughput, availability, any of them. And by looking at the entities which are related to each other, and then going into the specific entity, predominantly the one which occurs first in the chain, we can identify what is actually causing a chain reaction, what is actually causing the applications to go down. Right. So this is the root cause explorer in action. So we saw how the AWS observability solution, we can bring in data from different environments. This can be like my prod account, my staging account, my test account, dev accounts, etc. And how we can easily navigate using the Explorer view. I can easily navigate to all my related services over here. And we also saw how we can do troubleshooting by seamlessly navigating from the dashboard panels to metrics to logs. And we also saw the root cause explorer in action, where we are able to quickly look into the events of interest. And by checking the events which are clustered together, and by analyzing the event which happens first in the timeline series, we can actually find out why a particular application is having issues because of the interdependencies between various different elements within the AWS environment. So that is the AWS observability solution in action. So we have numerous apps which are covered as part of the AWS observability. So AWS Load Balancer, DynamoDB, EC2 Metrics, Lambda, RDS, API Gateway. You can see the ECS, Network Load Balancer, etc. We have an AWS observability solution, which has detailed documentation about how to deploy this particular solution and how you can make use of the root cause explorer, right? Sumo Logic is the next generation machine data analytics platform. Apart from the root cause explorer, you can use Sumo Logic for all the three predominant use cases, your DevSecOps sort of use cases. We have an app catalog which contains about 200 plus applications. These are the applications which are built by Sumo Logic, supported by Sumo Logic, and these are completely free. So an application is something like a template which contains previously, or I would say, predefined dashboards, queries, alerts, etc. You can bring in data from any of your services, AWS services, and once you bring in the data into Sumo Logic, all that you do is you deploy this application top of the data, and all these dashboards will populate with your data on it. So you can quickly deploy Sumo Logic, and you can quickly realize value out of the Sumo Logic platform. That's pretty much what I wanted to cover as part of the live session today. Feel free to raise any questions that you have. I see a question here. The question is, how can we add more services to the AWS observability solution? So we can actually add other dashboards, etc. So you can build the dashboards for other AWS services, and then you can actually link it to the Explorer view. The steps are actually documented in the AWS observability solution, and then you can follow that to achieve the same. I see a question here. The question is, how is the Sumo Logic solution is priced? The Sumo Logic platform is a complete SaaS platform. The solution is sized based on the amount of data that you send to the platform. It is something like 50 GB of data per day, 100 GB of data per day. So the factors that determine the pricing is the amount of data that you ingest into the platform, as well as the duration that you want to retain the data within the Sumo Logic platform. Please get in touch with us, and then we can help you to get at a tentative pricing for your specific requirements. There is a question, is there any built-in analytics? So the AWS observability solution has predefined content in the form of Explorer view, the applications, etc. The applications have pre-built analytics. You can get all those predefined views. And if you are looking at any more use cases to cover, apart from the predefined out-of-the-box content, you can always build those views. So we provide you a very powerful analytics platform using which you can always build your own views, and you can link it to the dashboards. What are the typical CloudWatch metrics Sumo Logic monitor for performance issues in AWS? So you can see with respect to the root cause explorer, we actually monitor the events of interest, the throughput, error, bottleneck, latency, availability, and load, right? So these are the events predominantly cause problems for your infrastructure and application. So we automatically track all of this for the services covered under the root cause explorer. Apart from this, you can see we have a lot of dashboards here. Let me open up one or two applications here. For example, the API gateway, and you can see under this API gateway, you can see all the entities covered here. You can see the various different metrics which are actually being tracked out of the box solution that we provide. And from here, you can drill down into a specific API name as well. And you can always use those filters, etc., to refine this particular dashboards. There is a question, can we add additional metrics apart from out-of-the-box supported metrics on which we can alert? Yes. So you can always build your own metrics panels. So you can create a dashboard, you can add your own metrics, and you can link it to the Explorer view or any other application dashboard that you have. So that way you can customize your existing data. You can customize your existing dashboards or out-of-the-box dashboards to suit your specific requirements. So you can always customize this to your specific environment. I think that's all the questions that we had as part of the discussions today. Thank you everyone for joining the AWS Observability live demo. We provide a 30-day free solution. So you can go to sumologic.com and you can subscribe for the free trial, and then you can evaluate the solution for 30 days. Feel free to reach back to us in case you have specific requirements, and we are happy to work with you. Wishing you all a very good day. Thank you.